Welcome to This Explainer. Look, polling is simple. Callbacks are undeniably faster. But when you're actually running in production, the absolute best choice depends entirely on your workflow, your traffic volume, and your failure recovery plan. Today, we're diving into how your choice between these two delivery methods can completely make or break your system's speed and reliability.
At a high level, this all comes down to a fundamental difference in communication. Do you want an architecture that acts like polling, where you literally have to keep asking, hey, are you done yet? Or do you want a callback system, where you just kick back and wait to be told? Both methods totally work, but they serve very different scales of operation. Are you just running a quick, tiny script on your laptop? Or are we talking about an enterprise-grade asynchronous pipeline? That scale is going to dictate your entire path.
Because really, the core problem is this. When your automation fires off a CAPTCHA solving task, your system actually needs a way to get that solved token back. You can't just toss the task into the void and hope for the best. You need a structured, reliable path to retrieve the answer. And well, there are two primary ways to make that happen. So, here's our roadmap for today's explainer. We'll start with delivering results, then look at why polling is simple but can be wasteful, why callbacks are fast but complex, how to actually make the choice, the hybrid standard, and finally, some common mistakes you definitely want to avoid.
All right, let's jump into part 1, delivering results, and the two paths to get your token. Moving right along to part 2, polling. It's simple but wasteful, and it's often the default approach. And honestly, polling is the default starting point for most developers for a very good reason. Basically, your system submits a CAPTCHA task, grabs a task ID, waits a couple of seconds, and then pings the result endpoint. It's essentially asking, is the result ready yet? If it's not, well, it waits and checks again. It just repeats this loop over and over until it finally scores the answer.
What makes polling so incredibly convenient is the absolute lack of overhead. I mean, it's a breeze to implement because you don't need any extra infrastructure. No public web servers to maintain, no complex webhook handling to stress over. Plus, it works flawlessly behind strict corporate firewalls. So it's absolutely ideal for local scripts, CLI tools, quick prototypes, and serverless functions, where you just need a straightforward answer without the hassle.
But, as you'd expect, there's a catch. Every single one of those checks, that's another API request. While you're waiting, you're literally wasting requests. A single solve could easily take up to 12 polling checks before the answer is actually ready. Now imagine multiplying those 12 checks by 1,000 tasks. Suddenly, you're just hammering an API with useless, noisy traffic. On top of that, it adds latency. If the solve finishes a millisecond after your last check, your system is stuck waiting until the next 5-second interval to find out. At scale, that is incredibly wasteful.
Okay, let's pivot to part 3, callbacks. They're fast but complex, representing the webhook evolution.
Now, let's see how callbacks step in to fix that wastefulness. With a callback, which you might also know as a webhook, the entire paradigm completely flips. During your initial task submission, your system simply provides a callback URL. Then, when the solving process wraps up, the service automatically sends a GET request with the result straight to your server. You submit the task, and you walk away. The service acts as the messenger, delivering the token right to your doorstep the absolute second it's ready.
As you can imagine, this is drastically better for high-volume workflows. You get instant notifications the moment the solve is done, which practically eliminates latency. There are absolutely zero wasted polling requests. You make exactly one API call to submit the task, and that is it. It's massively efficient when you're dealing with huge volumes, and it slots perfectly into modern asynchronous architectures where reducing API noise is a top priority.
However, and this is a big however, callbacks add a ton of responsibility to your plate. First off, you must have a publicly accessible endpoint, which immediately rules out running simple local scripts behind a tight firewall. You also have to manage webhook reliability, like what happens if your callback server goes down, what if the request just times out, or what if the callback randomly arrives twice, or your firewall outright blocks it. So yeah, callbacks are incredibly fast, but they demand a robust, resilient infrastructure on your end to handle retries and actually log the results.
Which brings us to part 4. Making the choice, let's look at the trade-offs at a glance.
So how do you actually decide which one is right for your current build? Well, just look directly at the API call volume. Polling takes roughly 3 to 12 requests just to grab one single result, whereas a callback takes precisely 1. Look at the latency. Polling adds anywhere from 0 to 5 seconds of delay based on your interval, while callbacks are pretty much instantaneous. But on the flip side, polling works right out of the box behind a firewall with zero extra infrastructure, while a callback absolutely demands a public-facing web server.
To make it super simple, here's a highly practical checklist for you.
Stick to polling when you're running local scripts, CLI tools, prototypes, tests, or really any workflow processing less than roughly 100 tasks an hour. But the moment you have reliable servers, real-time application needs, or a pipeline pushing well over 100 tasks an hour, you've got to switch to callbacks. They are a way better fit when you're building a dedicated microservice and need to keep that API volume down.
Now for the really cool part. Part 5, the hybrid standard, which is honestly the safest production strategy out there.
See, for actual production systems, the absolute safest choice isn't picking one or the other. It's using a hybrid approach. It works like this. Step 1. You submit your task with a callback URL to get that maximum efficiency. Step 2. You just wait for the webhook to hit your storage layer. But here comes Step 3, your ultimate safety net. If a timeout occurs and that callback just doesn't arrive within a specific time window, your system instantly falls back to pulling the result endpoint. This is exactly how enterprise systems operate. You get the lightning speed of webhooks fully backed by the unbreakable safety net of polling.
Let's wrap up the main concepts with Part 6, mistakes to avoid to perfect your pipeline.
Before you go off and architect your next solution, let's do a rapid-fire troubleshooting teardown. There are exactly 5 common critical mistakes we see engineers make over and over when setting up these delivery methods. Please avoid these pitfalls. Number 1, don't just pull forever blindly without measuring your request volume. At a low volume, sure, it's fine, but at higher volumes, those repeated checks create ridiculous, unnecessary load. Number 2, don't just switch to callbacks and cross your fingers. Your endpoint desperately needs proper uptime logs, alerts, and retry logic. Number 3, always match every token using its task ID. Otherwise, the wrong workflow is going to get the wrong token, and that's a nightmare. Number 4, never rely on a callback without that polling fallback we just talked about. You need that safety net. And number 5, please don't ignore HTTPS security, especially when you're transmitting sensitive tokens. To touch on a quick FAQ related to that last mistake, people ask us this all the time. Does the callback URL really need HTTPS? Well, while standard HTTP might technically function, HTTPS is highly recommended. If your callback handles any sensitive data at all, HTTPS is by far the safer, true production-ready choice. No question.
Here's another one we hear a lot. What happens if my callback server goes down right when the result arrives? Now, the service itself might retry sending the callback a few times, but as we covered, your system should immediately trigger its polling fallback strategy. Don't let your whole pipeline bottleneck just because a single webhook dropped in the middle of the night. Polling is absolutely the most practical backup here.
And finally, can one single callback URL handle multiple tasks? Yes, absolutely it can. One endpoint can handle the whole shebang. The trick here is that every single callback payload includes a task ID parameter. As long as you're diligently parsing that ID and matching the results properly in your database, a single URL is literally all you need to handle massive concurrency. So, it's time to ask yourself, is your automation pipeline currently wasting API requests, or are you ready to build a hybrid safety net? Take a hard, honest look at your architecture today. Are you endlessly burning through API calls just asking if a task is ready? Or is it finally time to upgrade to a robust, highly efficient hybrid pipeline? By understanding exactly when to use the simplicity of polling and the speed of callbacks, you can design a system that is not only lightning fast, but virtually unbreakable. Thanks so much for joining me on this explainer, and happy building out there.